We've just got 2 lectures today. We'll start with the readings one. Obligatory reminder that my lectures are not intended to substitute for actually doing the reading. So if I skip over slides and so on, it's incumbent upon you to actually read this stuff. There we go, I can see it. And at this point, I mean, how soon are midterms for most of you?
This started already.
See, there's a reason why your midterm in this class is until like near the end of next month. I want it well after all the others, and it's really your final.
Oh, I have an midterm right before finals.
Yeah. It's really your final in the class because there is no final in the class. It's me saying whether or not you actually did the reading and grasped all this, and if you do, I feel very, very comforted and said, yes, you're ready to go out in the world. Let's talk about architecture today, because your next deliverable. Oh, help me to remind you of this several times. Next week, we meet on Tuesday. And I will blast this out on Slack as well. But next Monday is a school holiday. In the spring, when they do that, since they have 2 Monday holidays, for the second one, Tuesday becomes a Monday instruction day. So we'll meet here 2 o'clock on Tuesday. Let's all keep reminding ourselves. Architecture. Architecture is one of the most contentious issues in software development and engineering because it so much depends upon it, and it's where the issue of the fundamental approach to solving your problem comes into play. Fred Brooks, and this again goes back to 1975, was I think the first to argue very strongly that you need a chief architect, or for a large project, a small architectural team, because the most important part is conceptual unity. It's knowing that all the pieces are stemming from a set of concepts, a set of design criteria that will achieve the end. I've already mentioned here when I came in to ARINC on their network management software for the Motorola Iridium project, satellite phones. I asked to see, I did 2 things. First I said, who's the chief architect? I literally went through the whole development teams and the managers and said, who's the chief architect? I had 6 different answers that I tabulated. The number 1 answer was no one. So the general consensus was there was no chief architect, and the other 5 answers that got varying numbers were different people within the team. First answer was actually the correct one. There is no chief architect. Because the next thing I asked to see were the architectural documents. What I got were 4 subsystem diagrams, which, as I mentioned before, if you try to actually match them up where they were supposed to talk to each other, they did not match up. Each was assuming interfaces that did not correspond to interfaces in the other subsystems. And one of the first things I had to do there was actually come up with a system architecture for their software. Come up with the overall design, and then rework the 4 subsystems so that they actually were talking to each other, and then distribute this out in the development team. Why do you think this concept of conceptual unity, of a coherent, consistent architecture, a set of architectural principles is so important? Any thoughts? Yeah.
Well, I think because to make anything worth anything, you can't just do it all on your own. And so you're going to be dealing with a lot of people's different ideas of how to make something work. And there has to be like a defined way for all those different thoughts to come together in a product that's useful.
That's a key answer. Unless you all have telepathy and can read each other's minds, you need some sort of guidance that says this is what we're trying to build. At Pages as the chief architect, I spent a lot of one-on-one time with all the other developers. Again, these were all top-notch professional developers. But I had to spend time with them saying, this is what you're building, and this is how it has to fit in. These are the principles it has to adhere to. And to the extent that each developer did that, it made it very easy to integrate all the various portions of the software together. Other thoughts? Yes?
I was going to say it needs to be in writing because I'm working on a team not outside of this class where we defined how all the different parts of this thing was going to interact, but we didn't write it down. We just talked about it. And now it's 5 months later, and people forgot details. And it was designed different ways than they should have, and we wasted a lot of time, basically.
At Pages, I made 3 diagrams. And these were on large, I had a big graph paper. I love graph paper. Discovered graph paper my freshman year and have loved it ever since. So, you know, I'm OCD, what can I say? Large graph paper pad. And I made 3 basic diagrams. One was a class hierarchy for the overall concept, actually for the entire desktop publishing system. One was a document composition diagram that showed the internal object structure of a document, which was our principal thing. This is a word processor, you're creating a document. You've got your document object, and here are the different object classes that it contains, and that those contain, and that those contain. And the third was a system interaction diagram. Here are the major systems of the software. Here's how they talk to each other, and in the process, what objects are passing around to each other. I used color pens. I worked on each one repeatedly. This was over a period, this is while we're still trying to hire people and raise money and so on. Worked on each one repeatedly until I was content with it. And as we hired each new engineer, I'd go down to Kinko's and get 3 big color copies of them, sit down with the new engineer and say, this is what we're building. So every engineer had that diagram. They had it reduced to a diagram, and when they were working on stuff, they could go back and look and say, this is how stuff is supposed to work. It's probably the best architectural job I ever did as a professional software engineer. And it was very effective because once we shipped, we could roll out new versions in every 3 to 4 months with significant feature expansion because the architecture allowed that and how everyone had implemented it allowed it. We turned our desktop publishing system into a drag and drop web page editor in 4 months. It was a WYSIWYG, what you see is what you get, web page editor, you drag elements out onto a page, drop them in there, press a button, and it made it HTML. This was in the spring of 1995. Most people didn't know what the web was then. Sadly, most venture capitalists didn't either. Because we had burned through all our venture capital, we were trying to get the money together to port this over to Windows, and the VCs were all like, what's the web? What is this stuff? It's telling that, and we finally had to close, we ran out of money, closed our doors summer of 95. 4 of the engineers went on and formed a company that did a small subset of what we had working with web pages and sold themselves to Netscape for $24 million. So sometimes winning the geek lottery is a matter of timing. Just so you know. Any other questions or thoughts before we move on from this? Yes?
So if you want to be an architect, how do you get that position? I feel like nobody, well, I'm wrong, but like, do they hire architects, or do you just hire programmers and then you choose one of those programmers to be an architect? How does it work?
This is a very good question. Part of it, I would argue that becoming a software architect requires a significant amount of experience in different domains so that you've seen the problems over and over again. And you can say, okay, if we do this choice, this is going to be a problem. If we do this, this is going to be a problem. And you know how to make the trade-offs. At Pages Software, or not Pages, excuse me, at Object Systems Group, where I was Chief Technical Officer, we would hire developers, architects, mentors, and so on, put them in the corporate, Fortune 500 corporations. And so we were always doing tech screenings of candidates to put in there. And there was one we were interviewing for a software architect position, and my good friend Bruce Henderson was doing the interview, and afterwards I said, how did it go? He said, well, he says, this is a very bright, very sharp young man, he says, but he doesn't have the depth of experience necessary to really be an architect. He says, if he were a fish, I'd throw him back in the lake and wait a few years. Now, the problem is there's a lot of emotion and ego tied up around those titles. You know, I've already told the joke here, how do you conjugate the verb to code? I architect, you program, he, she, it tests. That's sort of the status symbol that you'll find in organizations. Now, one of the consequences of that is you'll see a surplus of architects within an organization because this is a title handed out as a reward to senior developers. And if companies are not careful, they basically lose the conceptual unity concept. Now you can have a chief architect on each project, so it's not like you have one chief architect in the company. In theory, sort of the chief technical officer is the architect of architects, but his position is to oversee and make sure things are getting done. When I was at Ehring, I had to step in and be the chief architect for the Motorola project. Part of my responsibility during the 9 months I was consulting there was to take a small core of the best developers and train them to act as chief architects on separate projects. And so we spent a lot of time talking about, frankly, a lot of things we talk about in this class. Okay, chapter 5 also talks about architecture, and it tries to address the issue of staffing and adding people to a project. Basically, it says what you want is a loosely coupled architecture. What you want is to look, and some of you are already doing this, by the way, in your projects. You want to see if you can break down your system into 2 or 3 or more major components that are loosely coupled. In other words, you've got your APIs here, and everything is pretty much interactions or API or message-based or whatever solution, technology you're using. And you keep these stable. And as long as you're adhering to that, you can change stuff all day long within those circles, and the whole system keeps talking. What you want to do by loose couple, it means I can change whatever I want here, and as long as I'm continuing to adhere to the API that's published, the other system shouldn't care. Now, the reality is they will care, because I may make a change and suddenly I'm 10 times slower. Or I may make a change that suddenly assumes a different level of numeric precision. Or changes some of the underlying data structure. I think I've mentioned the concept of a deep API here, or a deep interface. Formal API is what you see, online, Java or whatever you want. It's like, okay, here are the various methods that you can call. Here are the fields that can be set or changed. The deep API says, if I'm going to use this method, I have to call this method first, And if the result is out of bounds, I have to call this method instead of the one I was going to call. That's not always well documented. And that's where you go to, things like Stack Overflow and say, okay, how do I really do this? And they say, well, you have to call this and call this, but in this case, you have to call this one instead. And that's the deep interface that you have to learn. You want to keep not just the formal interface standard, but you want to keep the deep interface stable. Or if it's going to change, give everyone a heads up, because they're going to have to go change your code. And they talk about why it's all wonderful. Any questions on this? I assume you're actually doing this reading. Okay, once again, Conway's Law, organizations should evolve their teams to achieve the desired loosely coupled architecture. A lot of you are doing this already. Again, notice how many of you wrote, something as simple as front-end, back-end. Or front-end, back-end database. A lot of you have organized your teams that way, particularly those of you with larger teams, and you're organizing the structure of your program you're developing in that way. These last 2 points are interesting. Architects should focus on engineers and outcomes, not tools or technologies. And Accelerate tries to emphasize that teams should be free to use the tools that work. Now, obviously, if there are going to be data or functional incompatibilities, you have to be consistent. But outside of that, you often have a situation where you will have teams that are being compelled to use a particular tool because the chief architect happens to like it. Not because there's an actual requirement or demand in doing implementation. So you've got this balance between making sure you maintain compatibility and forcing everyone to go a particular way because it's a hobby horse that the architect wants. And that last quote, what tools or technologies you use is irrelevant if the people who must use them hate using them. Because you drive out all the good people and you end up with the Dead Sea effect. Okay. From the Webster 4 readings, controlling IT costs using a maintenance architect. Big problem in larger organizations is maintaining existing code. You have legacy systems, and this is often where, as entry-level programmers, a lot of you may find yourselves working on legacy systems. They'll say, yeah, we've got this system that's used by 20% of the company. We can't retire it yet because we don't have a replacement, and here is a feature list and a bug list. Go work on it. And you find yourself having to do digital archaeology. You've got to figure out, how does this work? You've got to read the mind of all the programmers who have touched this before you. How many of you have had that experience of picking up legacy code and trying to figure it out? Oh yeah, and what's it been like? What been somebody had where it's like, no, it was awful. Yeah.
I mean, it's kind of fun. I felt like a detective. Now, I've made a lot of effort to document my findings so that the next guy who comes in doesn't have to do what I did, because I wasn't very productive for those 4 months. But it was fun.
Yes.
I have worked on code that was written in the 70s. A lot of code, like, I guess, how good it was written has changed a lot since then. So a lot of the naming conventions and commenting conventions were just terrible, and it was like so painful to work on.
Oh yeah, I've been there. Yes.
I remember it was like the 4th day of internship when I got a Slack message from my boss saying, find a bug, some information to help me locate it. And it was in a program that was about 400 lines long. It was a Python script. It was all in main. The whole thing. And it was just, I guess it was like 10 years old, and that tells you it's old in Python. That was fun.
I actually had a similar experience, one of my first assignments. First job out of college was General Dynamics, and there what they had is they had this pool of software engineers who served 10,000 engineers working at that facility in San Diego. So every week our Tom Reed, our manager, would say, okay, you know, I need a 20-hour-a-week programmer to work on this project for this engineer. Webster, you've got this, here's the number to put on your time card. So I was often working 2 or 3 projects at the same time, where I'd work on a project for a couple months and get moved to another one. One of the first was this, and I'm, you know, fresh out of college. It's this Fortran program that the code was only about 100 lines long and had about 8 or 9 go-to statements jumping back and forth. Naming conventions were like single letter variables, and 0 comments. And I'm sitting here trying to figure out what it's doing, how it's doing it, and how I'm going to fix it, or, you know, add a feature, whatever I was asked to do. This is actually a column I wrote back in 2008. Simply because this was for an online publication for CIOs. I said, consider having a maintenance architect. This is a good training position for a chief architect or a chief technical officer. Assign someone to study the architecture of your legacy systems, to document it, and to be the gate so that when you need to add a feature or fix a bug, this person says, okay, let me tell you what that's going to take, where you want to go, what you want to look at, and will actually oversee that work. I don't know of anyone who's adopted this particularly, but I thought it was a clever idea. But something important to remember is that most of the money spent on bringing a system into production will be spent after it is, or most of the money spent through the lifetime of the system will be spent after it's brought into production. About 60% of the money spent on a system through its lifetime will be after the 1.0 go live release, and it will be adding features, about 2/3 adding features and about 1/3 fixing bugs. That's what studies show. A real problem that organizations have, and I remember seeing this diagram at Fannie Mae almost 25 years ago. Here's time, here's IT cost, and what you have is money spent on new systems and money spent on maintenance. And here's your sort of your total budget, and you reach a point where maintenance is threatening to eat up your entire IT budget. So if you're not retiring systems or replacing them, you basically spent all of your company's money simply adding features to and or fixing bugs in existing systems and never get to actually put any new ones in place. This also is a driver in a buy versus build decision, which we'll talk about in a lecture. Any questions before we move on from here? Yes?
I find when I'm looking at old code, which it's my job to be the detective for, I sometimes feel the urge to refactor it.
Mm-hmm.
Is it rude to refactor somebody's old code?
Oh, heavens no. Heavens no. I think I've already told you the story. Did I tell you when I was at Apple? Got hired as a contract programmer at Apple. This is fall of '88. And this is where I mentioned this. They had purchased the source code for this multimedia software. And they wanted me to fix some bugs and add features. And there was this one routine where all the problems were. That was like 17 pages of Pascal. Again, you know, several dozen go-to statements. And not even brace, but sort of jumping back and forth in the middle of them. And I spent a week or two trying to figure out exactly what I did, and then I rewrote the whole thing from scratch. And the final version was like 2.5 pages, no go-to statements, and it did everything the other version did. So no, refactoring is as long as you save the original version, and as long as you have a sufficient test suite, make sure you have not inadvertently broken something. Refactoring is the best thing to do. Clean it up. Make it clear, make it simple, make sure the next person who comes after you doesn't have to go through that same problem. Any other comments or questions? The longest yard, I'm not going to spend a lot of time lecturing on this. Ruby and I had fun writing this. Ruby I met her, I was giving a talk at a software conference on leadership in IT based on a book I did called The Art of Where. And she at that time was, I'm not sure, she was basically the head of software development for a global logistics firm. And she brought me in to consult and work with her for development staff and so on. And we became good friends, and we're still good friends. And we wrote this because we're both football fans, and both had the same frustration, which is that, as we talked about earlier, management sees IT workers, far too often, as sort of interchangeable components. It's an industrial mindset. Well, we need 5 workers on this, and that's all we need, so let's pick 5 programmers at random and put them on this task. And our argument is that, no, this is much more like trying to build a winning sports team. And we both like football, so we used football as a metaphor. Could have used other stuff, but I still remain convinced the whole approach to hiring and building engineering teams is broken for most of industry. And a lot of this is based on my experience at Pages. First, my experience at Pages showed me how hard it is, even when you get great programmers, to get them to work together. Something not unknown in sports teams. And that even losing one programmer can really impact. I mean, look at Yoli. Look at our win-loss record with and without Yoli Childs on the basketball team. And so we went through and beat this analogy to death, which is why I'm not going to spend a lot of time here. But how many of you have been in situations where you know the organization that you're either working for or interviewing with is hiring people because they said, we need 10 more programmers and we'll hire whoever we can get? Have you seen that? It happens. And it's a bit like saying, okay, we need 10 more players for this football team. We'll take the first 10 who will accept our offer to get on the team. That may work in semi-pro, but even there, you're going to have problems. The point is that they hire people for the sake of hiring. They don't know how to evaluate them. Stop and think again. Let's take football, because I like football. Stop and think of the NFL Combine and all the tests, and they review performance in college. The problem is we don't have the equivalent of a college. Let's look at the film and see how they program. But the problem is it's more HR and management tends to say, do you check all the boxes? Do you have the right certifications? Do you have X number of years at this? And, are you willing to accept the salary we're willing to pay you? Okay, you're hired. And in my experience, especially we're first hiring people at Pages, and then after that, as CTO at Object Systems Group, screening people that we would put into corporations, on an hourly basis. And these were senior people, and they were getting good hourly rates. We did a lot of screening to figure out who to hire and who to use. And when someone didn't work out, we got rid of them quickly. I fired people before because of that. So we've got the recruiting issue, quarterback, chief software architect, coaching. How many of you have been hired into positions and then actually had someone sit down and work with you to say, let's review what you've done so far, and let's look at the things we can do that will improve your performance or make you a better person. As opposed to saying, go fix this list of 10 bugs and we'll see you in a week. Yes? Oh, and what's been your experience?
Nice. It improves really fast.
And were you raising your hand too? Yeah, what's it like when people actually sit down and say, let's help you be a better programmer?
I've seen that. So it's happened to me a couple of times. I got really lucky. I had spectrum of experiences. I had some coaches, we want to use that term, who are very technically oriented, and there's actually been some tension because, you know, they're up here, I'm not up there. And
Why don't you understand this?
precise,
It's so clear to me.
like Haskell monads and stuff.
Yes.
And then there's some other people who are a little bit more practical. And I think my experience working with all of them has been very helpful.
And again, a lot of my consulting experience in corporations, it's been basically as a coach. I don't go in to do the work, I go in to say, okay, to work with the people who are there and say, here are the things that can improve, here's what you want to consider, you should look at this. Yes?
I was just gonna say, I had one experience where I did have a coach and one where I didn't, and I was so much more motivated to produce good quality code and to like be a team player when I had a coach, because I felt like I could get help and my recognition, and that like my accomplishments were recognized. And so like, and the first internship was kind of like, I will do the bare minimum to check off the stuff off the list that I have to. And then the second place was like, no, I really want to like get after this and like produce really great code and like impress my coach because it's important to me.
Now, in theory, your manager should be your coach, or should have someone there to be your coach and should oversee that. I'll probably, we'll see, I usually, at the end of the semester, have my daughter, Crystal, come in and talk. She graduated with a BS in computer science from the U about 5 years ago now, and has been working here in Point of the Mountain as a software engineer. She's a senior software engineer at a med tech company. And she will tell you, quite frankly, she would not still be at the company if it were not for her immediate manager. Because her manager has worked with her, has set forth, and you know, Chris said, I want to get the senior software developer designation. What do I need to do? And her manager said, do this, this, and this. And she did it, and she got the title, she got the raise. She would walk on glass for this manager. She really would. And that can make all the difference. When I was at Fannie Mae, I was actually there overseeing about 25 consultants, but the person at Fannie Mae that I reported to directly was Carol Teasley. If Carol called me up tomorrow and said, Bruce, I've got this new project, would you come work with me? I would give it serious consideration. 25 years later. She was the single most competent person I had ever worked with. I learned a tremendous amount from her. And I have tremendous respect. And again, she did team building. She demanded the best of us, but she protected us from all the problems from upper management. We're gonna skip all that. Any other questions about this? And you know, I assume you read this, you can get from it what you can get from it.